All right, we need to find the second derivative at the point 6, 8. So let's find the first derivative. Let's do this using implicit differentiation. The derivative with respect to x of the left side and the right side equals 2x plus 2 times y to the first times dy dx. And the derivative with respect to x of 100 is 0. So we'll subtract 2x from both sides, divide both sides by 2y, and do a little bit of simplifying. So dy dx is equal to the opposite of x over y. All right, but we need the second derivative, so let's take the derivative of that. So we'll take the derivative with respect to x of the first derivative, and that gives us the second derivative. So we need the derivative with respect to x of negative x over y. We can use the quotient rule, or you could rewrite that and use the product rule. I'll just leave it this way and do the quotient rule. I'm going to rewrite this opposite as a negative x. All right, onward to the quotient rule. Low d high minus high d low. And the derivative of the denominator is just 1, but using the chain rule, then it's dy dx. All divided by low squared. So that's a negative y plus x times dy dx over y squared. And dy dx we already know is negative x over y. So let's do that substitution. And finally, let's simplify a little bit. I'm going to multiply by y over y. Why, you ask? To get rid of this y in the denominator. So let's distribute that. So we have y times negative y plus, and the y's cancel out on the second product. So we'll have x squared, and it's a subtract x squared. And in the denominator, we have y cubed. All right, they want to know the second derivative at 6, 8. Just substitute 6 for x and 8 for y into this expression, and we'll have it. This reduces to 50 over 256, which is 25 over 128, which is our answer A.